Hi students, in previous video we studied about Coulomb's law, but that was in scalar form. Now we are going to study same Coulomb's law in vector form. Coulomb's law represents force of interaction between two charges when they are placed in vacuum or any other medium. Now force is vector quantity, so we have to consider direction of force as well. So here we will take one example and try to obtain Coulomb's law in vector form again. So suppose we take one three-dimensional system. For example, this is x-axis, y-axis, and this one is z-axis. This is origin. We have two point-like charges which are placed at specific points. Suppose this is charge q1 and this is another charge q2. Right now we are taking both the charges as positive charges. Now position vector of charge q1 is suppose r1, and similarly for second charge it is r2. So this we consider r2. Now we want to find out force of interaction between these two charges. Suppose force is acting on charge q2 by q1. Now according to Coulomb's law, the force of interaction is always along the line joining these two charges. So here force acting on q2 charge due to q1 charge, which is F21, force on second charge by first charge, will be in outward direction. Similarly, force exerted by second charge on first charge. So force on first charge will be in this direction, that is represented by F12. So if we mathematically represent this force, then suppose we want to find out force acting on second charge by first charge. So this is equal to K Q1 Q2 upon distance between these two charges, that we write R21. This will be in form of magnitude and square. Here R21 is position vector of second charge from first charge. So this will be our R21 vector. R21, and magnitude of R21 vector is distance between Q1 and Q2. So this distance is magnitude of R21. Here this whole represents only magnitude of the force, but here we need direction also. So direction is always represented by unit vector along the direction of force, and force is acting in direction from first charge to second charge. So here we will write R21 caret. Now R21 caret is equal to R2 vector minus R1 vector divided by its magnitude. R2 minus R1 vector magnitude. So if we put this value over here, then equation will become F21 vector is equal to K Q1 Q2 upon. Now see, this will be multiplication. R2 vector minus R1 vector. Here in division it is already square, and this will be having one power. So total R2 minus R1 क्यूब. तो ये हमें Coulomb's law का फॉर्मूला वेक्टर फॉर्म में मिल गया. दिस इज फोर्स एक्टिंग ऑन सेकंड चार्ज बाय द फर्स्ट चार्ज. नाउ सिमिलरली if you find out force acting on first charge by the second charge, so that force will be in the opposite direction. Force acting on first charge by second charge is represented by this arrow. So here we have to take vector which is in this direction. That vector is represented by vector R12. So if we write F12 force acting on first charge by second charge, then it is equal to K Q1 Q2 upon R12 vector square caret R12 vector, like this formula. So F12 is equal to K Q1 Q2 upon here R1 minus R2 cube in bracket R1 vector minus R2 vector. Now see here, in mode R2 minus R1 or R1 minus R2, these both are same as a magnitude. R1 minus R2 magnitude is length of this one, and similarly R2 minus R1 magnitude is also length of the same points, distance between same points. So these two are similar, this one and this one are similar, and R2 minus R1 vector is opposite to R1 minus R2 vector. So here we can write that negative of K Q1 Q2 upon R1 minus R2 cube, this will convert into R2 minus R1. So if we put value from equation 1, this is actually similar to equation 1. So here F12 is equal to negative of F21. So force exerted by first charge on second charge is equal in magnitude and opposite in direction to the force exerted by second charge on first charge. That means here forces are created in a pair and action and reaction forces are equal in magnitude and opposite in direction. So here also Newton's third law is followed. So this was representation of Coulomb's law in vector form. Now we'll think, suppose we are having more than two charges and we want to find out force acting on particular charge. So in this case we have to find out multiple forces acting on that charge, and then finally we have to add all the forces. Now force is vector quantity, so addition will be also in vector form. So this concept is generally solved by superposition principle. So here we will take an example of superposition principle which is applied when we are given system of charges. So for simplicity we'll take three charges here. So first, what is superposition principle? What is superposition principle? When we are given a system of charges, minimum 3 charges should be there, then force acting on one of the charge is equal to force acting on one of the charge due to all the remaining charges is equal to vector sum of force exerted by each and every charge on it. So here we will take 3 charges. Again we are taking one coordinate system. One is x-axis, y-axis and z-axis. This is origin. Suppose we have one charge q1 and its position vector is r1. We have two more charges q2 and q3. q2 charge has position vector r2 and q3 charge has position vector, suppose r3. Now we want to find out net force acting on q1 charge due to this q2 and q3 charges. So what we want to find out? We want to find out force acting on first charge. Now who will exert force on first charge? First, second charge. Second charge will exert force in this direction. So this will be force exerted by second charge on first charge. So this is F12. Similar way, third charge is also exerting force and it will be along the lining joining these two charges. Right now we are considering all the charges positive. So Q3 charge will repel Q1 charge. So Q1 charge will feel force due to Q3 in this direction. So this force is F13 force. That means here two forces are acting on this Q1 charge in two different directions. So if we want to find out resultant of this force, then we apply vector addition method. So if we take parallelogram method, then we can easily find out resultant force acting on first charge. So this is graphical method to obtain resultant force acting on first charge. If we solve it mathematically, then F1 is equal to force acting on first by second charge plus force acting on first by third charge. Now if we apply Coulomb's law in vector form, then F12 is K Q1 Q2 upon R1 minus R2 cube R1 minus R2 plus K Q1 Q3 upon R1 minus R3 cube R1 minus R3. So this is force exerted on first charge by second charge in vector form, and this one is force exerted by third charge on the first charge. So here K Q1 we can take common, then Q2 upon R1 minus R2 cube R1 minus R2 plus Q3 upon R1 minus R3 cube R1 minus R3. So this is our resultant force which is acting on first charge. So similarly, if we have system of n charges, then force acting on suppose first charge due to remaining other charges is equal to F1 is equal to K into Q1. Then summation I starts from second charge to n charge Qi upon R1 minus Ri in modulus form and cube in bracket R1 minus Ri. So by this formula we can find out force acting on particular charge due to n other charges. So this principle is called superposition principle. So here we studied force acting on particular charge in vector form by Coulomb's law for two particular charges and for n particular charges.